So we'll solve one by one. We have solved numerical of Wheatstone bridge. Okay. We have not solved numerical based on Kelvin's bridge. So write down first equation, first numerical for Kelvin's bridge. So there is one figure for Kelvin's bridge. I will draw it for you. As the Kelvin's bridge is what? DC bridge. Don't forget to apply DC voltage. R1, R3, R2, RA, RB. This is RK, or you can call it as RY. Okay, RK, and this is what? RX. Okay. So what is given? They have given us the ratio RA to RB is 1000. Ratio RA to RB is 1000. R1 is 5 ohm. R1 is 5 ohm. And R1 is equal to 0.5 times R2. Then find Rx. हाँ बोला. मीटिंग सुरू झाली. माझं लेक्चर आहे 2 तास लेक्चर आहे. मी एन्व्हायरमेंटचं पण लेक्चर त्यांना सांगा परत फोन करून. 2 तास लेक्चर आहे म्हणा. ओके. Okay, so what they have given? Ratio of RA to RB is given. So we can write it as RB divided by RA is equal to 1 divided by 1000. Okay. And if you look in the previous equation, you can find that what? RA divided by RB is equal to R1 divided by R. Okay, this is known to us. So here, what we have condition from the diagram? From if we observe diagram, then we can write here RB divided by RA is equal to Rx divided by R2. Okay, Rx divided by R2. Here there is one mistake, so I will correct it. Here we have RB, sorry, RA, and here we have RB. So RB divided by RA is equal to RX divided by R2. So RB divided by RA is equal to RX divided by R2, which is equal to 1 divided by 1000. Okay, what they have given us? They have given us R1 is equal to 0.5 R2. So we can calculate R2 by, because we have R1. R1 is how much? 5 ohm. Okay, so we can rearrange equation. R2 is equal to R1 divided by 0.5. So R1 is 5. So 5 divided by 0.5 is how much? It is, yes, 5 into 10, it goes above. So 5 into 10 is the 50. So it is how much? 10 ohm, right? R1 is 10 ohm. Therefore, Rx is equal to how much? Rx divided by R2 is equal to 1 divided by 10,000. Okay, we have equation what? Rx divided by R2 is equal to 1 divided by 10,000, 1000. So we'll place the value of R2 here. So what we'll find? Rx is equal to R2 is how much? 10 divided by 1000. Okay, so Rx will be 0.01 ohm. Rx is equal to 0.01 ohm, and this is our final answer. So while solving the numerical, you have to draw first diagram, then write the given things, then write equations for balanced condition, and then solve the numerical. Okay. Everyone got this? This is Kelvin's bridge numerical. Okay, now I will give you another example. Okay, I will go towards the next page. So a capacitance comparison bridge, write down capacitance comparison bridge. You are with me, all of you?
Yes, ma'am.
Or am I moving ahead? Yes,
No, ma'am.
you are with me now?
Yes, ma'am.
Yes, ma'am.
If you're lagging, then you can tell me to wait. Okay, otherwise I will
Okay,
go
ma'am.
ahead. And so second numerical, write down a capacitance comparison bridge. Write it down, a capacitance comparison bridge. Capacitance comparison bridge is used to measure capacitive impedance, is used to measure capacitive impedance at a frequency of 2 kilohertz at a frequency of 2 kilohertz. The bridge constants at balance are C2 is equal to 100 microfarad, R1 10 kilo ohm, R2 50 kilo ohm, and R3 is 100 kilo ohm. Okay, and you have to find out equivalent series circuit of unknown impedance. Find equivalent series circuit for unknown impedance. Means what? We have to calculate fourth arm of the capacitance comparison bridge. Okay. So first draw circuit diagram for the bridge. Okay. Tell me the parameters of first arm. What is circuit diagram for capacitance comparison bridge? First arm is purely resistive. Second arm is again resistive. In third arm, what we have? Capacitor is in series with resistor. And again in fourth arm, we have capacitor CX in series with resistor RX. Okay, so this is C3 and this is R3. Then don't forget to apply power supply, draw detector. This is our circuit diagram. Okay, so write all the given things. Frequency is given here, but there is no need of frequency, right? What is final equation for the capacitance comparison bridge? Rx is equal to R2 R3 divided by R1, and Cx is equal to R1 divided by R2 into C3. So place all the values, given values in the equation, and calculate unknown capacitance and unknown resistance. Okay, and what they have told us, find the equivalent series circuit. Okay, so you have to draw the circuit for this one. So what is equivalent series circuit? Which contains unknown capacitance and unknown resistance. Okay, so this is diagram for equivalent series circuit. This is Rx and this is Cx. So you have to just write values over here after finding it. So tell me value after calculation. What is Rx and what is Cx? Do fast. R1 is what? R2 multiplied by R3. R2 is how much? R2 is 50K. R3 is 100K. So 50K multiplied by 100K divided by R1. R1 is 10K. So what we'll get here? 10 divided by 50. So here we get 5. Okay. So Rx will be 500 kilo ohm. This is the answer for R2. Okay. Then Cx R1 is how much? R1 is 10K, R2 is 50K. Okay. Multiplied by C3. Okay, here I have written C2. So what should I write here? C3. Okay, there is one mistake by me. So C2, C3 is 100 microfarad. Okay, so we'll convert that microfarad into farad. So 100 into 10 raised to minus 6 farad. Okay, so here we'll write 100 multiplied by 10 raised to minus 6. So Cx will be how much? 10 into 10 raised to 3 divided by 50 into 10 raised to 3, 100 into 10 raised to minus 6. Okay, so 50 to the 100. So what we get here? 10 raised to 3, 10 raised to 3 will get cancelled. So 20, 10 into 2, 20 microfarad is the answer for Cx. काय केलं लक्षात आलं? All units are in farad and ohm. Okay. आपला रजिस्टर जो होता तो किलो मध्ये होता. So I have converted it into ohm. 10 into 10 raised to 3. 50 into 10 raised to 3. ठीक आहे. असं का केलं मी? Because I have considered capacitor in farad. Okay. 100 into 10 raised to minus 6 farad. हे युनिट फॅरेड मध्ये आहे, त्यामुळे हे युनिट मी काय केलंय ओहम मध्ये घेतलंय. If you do not consider this one, then you will get wrong unit at the final. So our equivalent series circuit diagram for unknown impedance is what? Rx is 500 kilo ohm and Cx is 20 microfarad. So this is final answer. Okay. Over. Is there any doubt? No? Then we'll move forward. Okay. So, third numerical. Okay, write down a Maxwell bridge. Maxwell bridge is used to measure inductive impedance. Maxwell bridge is used to measure inductive impedance. The bridge constant at balance are the bridge constants at the balance are C1 is equal to 0.01 microfarad, R1 is equal to 470 kilo ohm, R2 is equal to 5.1 kilo ohm, and R3 is equal to 100 kilo ohm. Okay, so first draw circuit diagram. Okay, draw this one. Don't skip circuit diagram. If you do not draw circuit diagram, you will lose 2 marks. Okay, the question of bridge is generally for 9 marks. Okay, and if you skip circuit diagram, then you will definitely lose 2 marks. So don't forget to draw circuit diagram. So at the balance, this is given. What we have to calculate? Find unknown impedance. Okay, find unknown impedance Lx. Okay, so this is what Maxwell's LC bridge. Okay, in Maxwell's inductance bridge, what we have? Two inductors. It is inductance comparison bridge. In Maxwell's inductance, Maxwell's LC bridge, what we have? We have one inductor and one capacitor. So first write balanced condition. Rx is equal to R2, R3 divided by R1. And for Lx, it is R2, R3, C1. So place all the values and find out the answer. Okay, do this as homework. येईल ना करायला? Just place the values of R2, R3 and R1, R2, R3 and C1 and calculate your answer and tell me your answer. Yes, I got one answer. Rx, what is 500? Is this previous one? Okay, I got answer from Ritesh. How much? Rx is equal to 1.21. Is it 1.21? Check it again. R2 is 5.1 K multiplied by R3 is 100 K divided by R1 470 K. You're close to it. Yeah. Okay, Rutuja posted the correct answer exactly. Sakshi and Rutuja. The answer is 1.085 or we can write 1.09 kilo ohm. Okay. Ritesh, you are close to answer. There is some minor mistake in your answer. Check it out. Okay. Lx. What is value for Lx? R2 is how much? R2 is 5.1 K multiplied by R3 100 K multiplied by C1. C1 is 0.01 microfarad. So again here, this one is in micro and all other are in kilos. Okay. In Rx, what happens? Every parameter is in kilo. So we have not converted it. So here you require to convert it. Okay. So 5.1 into 10 raised to 3 into 100 into 10 raised to 3 into 0.01 into 10 raised to minus 6. ठीक आहे, असं करून कॅल्क्युलेट करा. किती येतंय? युनिट इज व्हेरी इम्पॉर्टंट. डोंट फॉरगेट टू राईट युनिट. व्हॉट इज युनिट? 5.1 Henry. Okay, we always measure inductor in Henry. So this is your final answer. Okay, don't forget to draw circuit diagram. I have not drawn this. Okay, draw it first. Okay, then we'll solve one example for Hayes bridge. Find, okay, note it down. Find series, equivalent inductance and resistance with following components of arms, are of arms R2 10K, excuse me, R1 2K, C1 is 1 microfarad, R3 is 1 kilo ohm, and omega is 3000 radian per seconds. Okay, so what you require to find out? Lx and Rx. So you have equation for Lx and Rx. What is that equation? Rx is equal to omega square R1, R2, R3 into C1 square divided by 1 plus omega square R1 square C1 square. Similarly for Lx, what we have? We have equation R2, R3, C1 divided by 1 plus omega square R1 square C1 square. Right? So place the values of R1, R2, R3, C1. Again, C1 is in microfarad. So don't forget to convert it into farad. Okay. And find out your answer and post it here. Okay, post your answer, calculate it. Till I will write one more numerical, which is homework for you. Okay, this is homework for you. Yes. What is answer? Rx is how much? No. Yes, Alex is right. No, no, not at all. You're not close to the answer. Why? Omega is how much? 'No, you're getting wrong answer. Why this is so? Omega is, check out this first, omega square. R1 is 10K. I will write it as 10 raised to 3 multiplied by R2 2 into 10 raised to 3 multiplied by R3. R3 is 1K. So 1 into 10 raised to 3 multiplied by C1 square. C1 is how much? It is C1 is 1 into 10 raised to minus 6 square, bracket square. Okay. C1 square आहे. C1 किती आहे? 1 microfarad. Divide by 1 plus again omega square, that is 3000 square multiplied by 2 into 10 raised to 3 square multiplied by 1 into 10 raised to minus 6 square. Now calculate this one and tell me answer. Yes, Alex is correct. Alex is correct, Siddesh. 0.27 Henry, or you can write it as 270 millihenry. Okay, Siddesh got the answer for Alex. Alex is equal to 470 millihenry. Sorry, 270 millihenry, not 470. Unit is very important. Don't forget to write unit. You're not getting correct answer for Rx. This term is plus. ही जी term आहे ती plus आहे. 1 plus. So check whether you're writing this one correct or not. Yes, Atharva got the correct answer. The answer is 4864.87 ohm, or you can write it as 4.8 kilo ohm. This is final answer for Rx. Okay. So write the next question, which is for homework. Okay, find out which bridge is this. and post your answers in and message your answer. Tomorrow there is lecture of environment, na?
Yes, ma'am.
So again, I will adjust that lecture for your seminar. Vaishnavi. Okay, so everyone got the answer or not? साक्षी करेक्ट आन्सर मिळालं का नाही RX चं?
Yes, ma'am.
रितेश. ओके ठीक आहे. नेक्स्ट न्यूमरिकल लिहून घेतलंय. नेक्स्ट न्यूमरिकल लिहून घ्या. कोणता ब्रिज आहे ते फाइंड आउट करा आणि त्याचे आन्सर आहेत ते पोस्ट करा मला व्हॉट्सअपवर. चालेल?
Okay, ma'am.
हा ठीक. सेमिनार आज कुठल्या बॅचचा घ्यायचा होता सेमिनार आपल्याला? सेमिनार साठी कोणत्या बॅच? वैष्णवी त्यांच्या बॅचचा घ्यायचा होता ना? शशिकला, आर यू देअर?